looking at swirls and trying to take more of a geologic approach to the whole story. And if you listen to Larry Taylor this morning, the bottom line is to mature the regolith, you don't need either solar wind bombardment or micrometeorite bombardment. So it's not clear exactly what's going on. Basically, this was part of the problem here is Dave, who is hanging out in China at the moment, sent me a random set of slides and said, have a good time. So I disavow anything I say. Basically, we wanted to cover what we know about the swirls. You've heard a lot about that this morning. Some of the hypotheses, you've heard that as well, and talk about some recent work that bears on the problem. Reiner gamma, you've heard about this over and over again. Some of the key points that have also been mentioned is that when you look at the albedo structure, it's incredibly complicated. It's very small scale variations, and so if you're arguing for some magnetized body below the surface to generate this magnetic field, then there's something much more complicated going on than just one or two dipoles next to each other, which is not to say those models are not correct, but there's a lot more structure. In addition, when you actually look at the magnetic observations that were made on the surface during the Apollo program, the surface magnetic fields vary enormously over very short distances. So you have to take that into account, largely because the stuff is all churned up and broken up due to the impact. So any remnant magnetization gets mixed. Okay, you've heard all this before, the various anomaly origins. Again, Reiner gamma, and the point of some of this is to actually look in detail at what's going on the surface. You saw that virtually the same picture a few minutes ago, except it was vertical. North is this way, and you can see some of the intricate structure. You can see there are random craters scattered across here. You can see these dark lanes in here. One of the more interesting things is up here is this old crater, the floor of which is lighter than the lane on either side of it. So whatever process is going on is sort of different within this crater than it is nearby. You saw this very same plot a few minutes ago. This one's just pixel by pixel. The interior lanes are both brighter than, darker than, and the same albedo as the area outside. Some of this is a function of how many fresh craters there are in that particular area and how it gets mixed. But it's not entirely clear that the albedo is necessarily darker than the outside areas, has been suggested in a couple cases. One of the things that we were looking at is secondary craters. This is also Reiner gamma. There's a big herd of secondary craters over here. You can see the surface is all splotchy. You get over here and there's not so many. So while there are secondaries in some of the less well-studied ones, there are lots of little secondary chains associated with the swirl patterns. It's not the only possible explanation for what's going on. In addition, you've got small craters that range in diameter from a few meters to a few tens of meters up to about 100 meters that are exposing dark material inside the bright areas. And you can see in these highly stretched images, there is some dark material being exposed, which suggests a couple things, that whatever process is going on here seems to be mostly a superficial process, because you can excavate darker material from depth. And there's a whole set of issues that go along with recently disturbed material and how bright it is and what the grain size distribution is. But it would argue that whatever process is going on is not intrinsic to the visual albedo material properties at depth. Otherwise, you would simply expose it. It would be brighter because it was fluffed up. So there is some dark material at depth, which suggests that the albedo patterns don't persist with depth. There's lots been talked about with the magnetic field. Reiner gamma has a well-defined magnetic field. There's lots of other anomalies, swirls that have albedo features associated with them. Some of the problem with these data from Lunar Prospector is that they're fairly low resolution, and clearly the field at the surface is going to be much more complicated than what's observed in these things. And it was also correspond to some of the intricate structure, presumably the intricate structure you see in the albedo pattern. Okay, so this is sort of a summary again, that there are dark lanes in between here, and you can see this tail going off up here. It was just mentioned. You get this bright pattern out here, and there's lots of details. We've also been looking at as has been said before, there is possibly a slight thermal anomaly associated with this. in the case of Reiner Gamma, there's absolutely no topographic signature. You can see in the both the LOLA data and the LROC DEMs that there's essentially flat across here. There are places where there's topography associated with the swirls, but that's nothing to do with the swirl per se. It's simply laid across the underlying surface, be it highlands or low or Mare or both in some cases. The argument's been made in the past that the magnetic anomaly is standing off the solar wind, and so you're getting less space weathering in here, and so you're getting a different albedo, and you're changing both the overall brightness as well as the UV part of the spectrum. Again, listening to Larry Taylor this morning, he was arguing that you can get space weathering and essentially changing the oxidation state of the iron without any influence of the solar wind, that you can get the hydrogen out of vaporized silicates, and so you can make the oxygen, you can reduce the iron and produce weathered soil without any space weather interaction. So that would argue that even if there is a magnetic field there, it may not be relevant to the process that's going on. He also showed, though, that you seem to be able to get nanophase iron on asteroids where the impact velocities are very low. So it's still not clear exactly what's causing the space weathering, and so the effect of the ambient magnetic field in these cases becomes a little more unclear. Cometary impact has been one of the suggestions, both in terms of creating a magnetic field and scouring the surface. One of the interesting things that is observed that might lend something to the scouring phenomenon. This is a picture of the Apollo 11 landing site. One of the things we see at all the landing site is this bright area surrounding the LEM that's due to scouring of the surface by the descent engine. And then you can see it's darker where the crew is walked. We see this phenomenon not only at the Apollo sites, but any place that something's landed, both the surveyor and the lunar site. So you can obviously brighten up the surface by changing the texture simply by the descent engine. So you could imagine, I guess in a sense, if you had a cometary impact and you had some vapor cloud roaring across the surface, it could disturb the surface in a similar way as this. I guess, okay, there's a scale bar, 50 meters. These extend out about 150 meters or so, and you can, in the cases where the LEM came down in sort of stages, you can see the trail going off, and you can see it getting wider as the surface gets impinged more and more by the plume. This has been talked about in terms of the accumulation of feldspar-rich dust grains that are brighter through some sort of electrostatic mechanism. We haven't done much of this, as was just said. Carly has proposed some sort of combination of roughing up and changing the surface fairy castle structure to produce this. These are Apollo footprints, and you've got forward scattering here, and you can see where they're very smooth, where the boot prints are, they're bright. Some of the other things we've been looking at are in addition to, we've been looking at some of the same stuff that Tim has been looking at, trying to look at the thermal characteristics of the features. We've also been looking at some of the old Clementine data, the optical maturity stuff, and mini-RF. And for example, mini-RF presumably is looking not only at the surface, but some depth below the surface. And basically, in the case of Reiner Gamma, there's no real change in the properties going across the swirl, and so this indicates that at radar wavelengths, the block distribution and the surface roughness is all about the same. There's also been, Tim just showed this exact data set, so there is a little bit of an anomaly here. It may be due in part to the temperature. It may also have to do with some compositional effects. Yeah, this is, Dave sent me the same slides. Did you send him the slides? And with the help of Brett Denevi, we've also been looking at the UV, which is what Amanda talked about earlier. And so there's really not much difference here. There obviously is some ultraviolet signature, which suggests something about the weathering process. Brett's been trying to compare all over the moon the UV and the magnetic anomalies to see what correlation is. She's got a paper submitted to the Icarus special issue, and there is a correlation, is suggesting that there is something going on here, but the extent to which the micrometeorite bombardment and the solar wind causing the effects is still a little unclear. And I'm going to quit there before I get in further trouble. emailed it.